let's integrate arctan x dx. So I think this is an interesting problem because it might not be the most obvious to solve, and it could look confusing because we don't know what the integral of arctan x is, and don't get confused with its derivative. It's not equal to 1 over 1 plus x squared, but we could use that fact. So we could solve this integral using integration by parts. So we know that our integral, to do integration by parts, our integral must be in the form u dv. And to assign our u and dv, we could use the LIATE acronym, where L is for logs, I is for inverse trig, A is for algebra, and then T is for trig, and then E is for exponentials. And again, I need to mention that this doesn't always work, but in most cases it does, and in this case it does as well. So based on our acronym, U would be equal to arctan x. So D would be equal to 1 over 1 plus x squared dx. And then dv would just be equal to dx. And if you integrate dx, you're going to find that v is equal to x. And then we plug everything into our equation that we used to do integration by parts. So uv minus the integral of v du. In our case, it would be, our u is going to be arctan, and then v is x. So x arctan x minus the integral of x over 1 plus x squared, because du is equal to that, and then v is equal to that, and dx. So I'm going to do this integral on the side. So we notice that we have a function in the bottom and then its derivative on top, and that tells us that we could do a u substitution. But we already used the variable u, so I'm going to do t substitution instead. So t is going to be equal to 1 plus x squared in this case, and dt is going to be equal to 2x dx. And you could write for, because in our integral we have x dx, we could rewrite as x dx is equal to 1/2 dt, and then rewrite your integral in terms of your t and dt. So it's going to be equal to, I'm going to take that 1/2 out. So 1/2 of 1 over t dt, and now this is much easier to integrate. So integral of 1 over t is just ln t, don't forget that 1/2, and then sub in what t was. So 1/2 ln 1 plus x squared. And now that we've done this part, we could plug it back into our original solution. So x arctan x minus 1/2 ln 1 plus x squared. Then don't forget your arbitrary constant plus c. And that's it.